let's talk about prime factorization, and we're going to look at each word there. So prime and factorization, and that'll make sense as to what the whole thing is. So starting with prime, prime numbers is what that's referring to. And what are prime numbers? Prime numbers are numbers where the only factors of that number are 1, maybe I'll write the number 1, are 1 and itself. Okay, so factorization, let's talk about what factors are. Factors are numbers that you multiply together. Factorization would be defined as factorization breaking a number down to its prime number factor. I want to make a quick correction that factorization is really just breaking any number down into any of its factors. And prime factorization is exactly what I wrote there in green, breaking a number down into its prime factors. So just wanted to clear that up. So when we factorize something, we're figuring out what prime numbers would I have to multiply to get to that number. And then prime numbers, again, numbers where the only two numbers that multiply to make that number are 1 and itself. Different than composite numbers, which are numbers that can be broken down into factors other than 1 and itself. So an example of a prime number might be, let's see, 7, right? Because 7 times 1 is the only, 7 times 1 is the only multiplication problem that we can think of that exists where you can multiply two whole numbers and get 7. 13 is another prime number because the only two factors, whole number factors of 13 are 13 and 1. So actually, in these two examples, both these expressions, 7 times 1 and 13 times 1, these are prime factorizations of both 7 and 13 respectively. So, but that already makes sense. We know that prime numbers are only going to have 1 and itself as the factors. So let's look at some composite numbers and prime factorize those. Let's look at 30. So right off the bat, if you notice a number is even, you should know that 2 is a factor of it because we can cut it in half. So what this prime factorization is going to look like is we'll draw these things called factor trees. So start by splitting up the number into two factors that you know. So like I said, 30 is an even number, so I know 2 times 15 is going to be 30. And then now split those factors up further into prime numbers as far as you can go. So 2 is a prime number, so I'm going to circle it. Can't split that up any further than 2 times 1, which there's no point in writing that. But 15, I can split that up into 5 times 3. And I can't go any further than that because 5 and 3 are also prime numbers. So the final answer for what is the prime factorization of 30 would be 2 times 5 times 3. We've broken 30 down into its prime factors, and it cannot be broken down any further. How about 120? So I see it ends in a 0. So I know we can divide this thing by 10, or that 10 is a factor of it. So why don't I do that right off the bat? I'll do 10 times, what's that going to be? 10 times 12. 10 times 12 is 120. I can split the 10 up. Factors of 10 would be 5 and 2. And both of those are prime numbers, so almost done here. And then 12, we can split that up into 6 times 2. So we got another prime number there, the 2. And then 6 can be broken up into 3 times 2. So there are our last two prime numbers. So the prime factorization of 120 would be 5 times 2 times 3 times 2 times 2. So I just went left to write there. Since I have here 2 times 2 times 2, I can write that as 2 cubed. So another way we could write this answer, and this is totally fine, but you probably want to write it using exponents. So I'll write it as 2 to the third power, because I got 2 times 2 times 2, times 5 times 3. So that's probably the more correct answer. All right, 17. It's not an even number, so we can't divide it by 2. If we count by threes, 3, 6, 9, 12, 15, 18. So 3 is not a factor. 4 can't go into 17 evenly. 5 can't. 6 can't. 7 can't. 8 can't. 9 cannot. 10 cannot. So this is actually a prime number. So its prime factorization, again, is just itself and 1. So 17 times 1. Can't do any more than this. All right, 208. So this is an even number, so I should just immediately recognize that 2 is going to be a factor. So I'll split this up into 2 times, that's going to be 104. And then 2 is a prime number, so we're not going to split that up any further. 104, that's also an even number, so I'm going to split that up into 2 times, let's see, 2 times 50 is 100, so 2 times 52 would be 104. Again, we got our prime number 2 there, so I'll circle it. And then 52, that's also an even number, so I will split that up into 2 times 26, circle the 2. 26, another even number. I'll get 2 times 13. And then 13 we saw at the beginning of the video is a prime number, so I can't reduce that any further. So I've got 2 times 2 times 2 times 2, or 2, so write it down here, 2 to the 4th, and then times 13. So there is our prime factorization of 208. All right, looking at 63. So really you need to know your multiplication tables. If you don't know those, you need to stop watching everything you've watched up to this point and go and practice that until you're blue in the face, honestly. If you don't know your multiplication tables, everything after at this point really should be hard, and that will make things a lot easier if you know those. So 63, not an even number, so I can't divide it by 2. A cool divisibility rule trick, actually, if you want to check if a number is divisible by 3, add the digits. So 6 plus 3 is 9. Is 9 divisible by 3? Yes, it is. 3 can go into 9 3 times, so that means 63 is divisible by 3. And that's going to be 3 times 21. 3 times 20 is 60, and then if you add another 3 to give you 21 threes, you'll have 63. So 3 is a prime number, so I'll circle it. And then 21, if you watch football, you should know that that's 3 touchdowns with the extra points. So assuming a touchdown is 7 points, that's 3 touchdowns, or 7 times 3. And then both of those numbers are prime numbers, so our prime factorization here is going to be 3 squared, because I got the 3 times 3 here, and then times 7. All right, last one, 225. If something ends in a something 25, 25 is a factor. Think of quarters if you even have worked with change in your life. Maybe if you're in middle school or high school, you don't even know what change is. But if a number ends in 25, you know that it is divisible by 25, or that 25 is a factor of that number. So I'll split that up into 25 times, well, I know 25 times 4 is 100, and then 25 times, add another 4, 25 times 8 is 200. So if I add one more 25, that gives me 9. 25s, that'll be 225. So 25 times 9 is 225. I can split both of those numbers up, and actually both of those are perfect square numbers, and I'll show you what that means. 25, we can get that by doing 5 times 5. So we're squaring 5, that's why it's called a perfect square. And same thing with 9. 3 times 3, or 3 squared, is 9. That's why it's also a perfect square. All 4 of these numbers are prime numbers, so my prime factorization is exactly that. 5 times 5 times 3 times 3, or 5 squared times 3 squared.